Hi, I'm going to talk about 5G C-V2X technology evolution. We are going to do an overview of the technology and also demonstrate a use case using the prototype that we have developed for the technology. So there's LTE-V2X, which was for basic safety. Now we have 5G V2X, which is for advanced services, and they will coexist together in a car. This will enable new use case for V2V, V2I, V2P, and can be combined with AI. 5G V2X offers several enhancements, including higher data rate, low latency, and reliable multicast. This gives benefits like sensor sharing and on-the-fly distance-based reliability, the distance part being very new feature that we introduced. Qualcomm is actually enabling not just 5G and C-V2X and 3GPP, but it's active across all V2X standards at the application layer. We're going to start with the use case where we are going to demonstrate an emergency vehicle approaching intersection, and there are two other vehicles that are approaching the intersection. And what you can see is that there's an obstruction between vehicle A and emergency vehicle. By contrast, there's no obstruction between vehicle B and emergency vehicle, so the radio environment is also much better in that direction. And what you see is that emergency vehicle is trying to approach the intersection, but then vehicle A does not stop at the intersection, so emergency vehicle has to slow down for vehicle A to pass, and then it can cross over. So in this view, we have the map view and the views from emergency vehicle and vehicle A. The cars have started, and again I want to point out that there's an obstruction between vehicle A and emergency vehicle. This makes the radio propagation much difficult compared to, let's say, between emergency vehicle and vehicle B. And now what you will see is that the cars have reached their speed, and now they're calculating a target radius basically. So in this case, both of them are targeting a radius of 70 meters to avoid collision. And as soon as the emergency vehicle is within that target radius, the detection happens first for vehicle A and then for vehicle B. So you see the non-outside vehicle is getting detected earlier slightly, and they are roughly getting detected at the same time. This enables the emergency vehicle to sort of get a warning, and it slows down and avoids the accident with vehicle A. Vehicle A now is passing, now emergency vehicle passes the intersection, and then vehicle B crosses the intersection. So now we are going to do the same use case, but what we are going to do is change the speed of the misbehaving vehicle, which is vehicle A, to a higher speed. So it's the same intersection, again the same vehicles, and the views are from map view and also from emergency vehicle and vehicle A, B. Vehicle A is traveling at a higher speed, so it's calculating a target radius of 80 meters, whereas vehicle B has a target radius of 70 meters. And as soon as the emergency vehicle is within that radius, vehicle A gets detected first, even though it's not line of sight. And soon vehicle B also gets detected as soon as it's within the radius. And because of this, there's a warning which comes up saying that vehicle A may be misbehaving, and the emergency vehicle slows down because of this. We can again demonstrate the same use case with sensor sharing. Here the idea is that because 5G V2X has a much higher data rate, car can share information not only about itself, but other vehicles that it's observing using camera and radar and LiDAR in the neighborhood. So we'll do the same experiment, but with vehicles, non-C-V2X vehicles in front of vehicle A and vehicle B, and they're being observed by vehicle A and vehicle B respectively, and then transmitting information about them to the emergency vehicle. So again, this is the intersection with the different views. As you can see, there are two more vehicles in front, one each in front of vehicle A and vehicle B. So now you see that as soon as you enter that radius, first vehicle B is detected, and then soon vehicle A is detected. And now they're also sharing about information about what they're seeing. So what happens is that the emergency vehicle knows that the vehicle in front of vehicle A is misbehaving, so it slows down. In conclusion, 5G and C-V2X has a lot of features. One of the key features is distance-based reliability. We demonstrated that, and the advantage of distance-based reliability is that it allows uniform performance across different radio environment, which fundamentally changes the experience that you get for V2X.